Okay, let's dive into this. Welcome to the Explainer. Today, we're unpacking a genuine game changer in the AI space, Quaffos 9b. We're going to explore exactly how free, strictly private, and totally offline AI is fundamentally shifting what we can build right from our own desks.
So just imagine this for a second. What if you could take a highly capable Claude-style intelligence, that really incredible reasoning and creative writing ability, and run it directly on your own Mac, entirely for free? I mean, no subscription fees, zero cloud computing costs, no annoying token limits, and absolutely no privacy risks, because not a single byte of your data ever leaves your machine. It sounds a bit like science fiction, right? But that is exactly what we're breaking down today.
Section 1. Meet your local AI.
Section 2.
Under the tech hood.
Let's move to and see how this builds. Because honestly, it takes a very deliberate stack of engineering choices to squeeze this much brain power into such a tiny box. First off, it starts with a really strong open base model, Qwen 3.59b. Then it undergoes this specific post-training that's hyper-focused on Claude-style creative reasoning. Third, it uses a clever technique called yarn to dramatically stretch out its memory. And finally, it gets compressed down using llama.cpp and is run via Ollama. That makes it light enough for a standard laptop to handle without breaking a sweat. It's kind of like compressing a massive sprawling library into a single paperback you can just carry anywhere.
Section 3. The context window reality.
Now, the headline number you are going to see absolutely everywhere for Quifos 9b is this: 1 million tokens. I mean, that is a massive context window. In theory, a window that size means you could feed it entire books, massive code bases, endless chat histories all at once. It sounds almost too good to be true for a tiny local model, doesn't it?
Well, here's the catch. The real limit? It's your RAM. That 1 million token number is a ceiling, not what you're going to get straight out of the box. Ollama actually loads the model with a much smaller window by default. And why is that? Because the longer the context window you try to use, the more RAM the model just completely eats up. In practical testing, pushing that limit can cause a long response to just suddenly cut off. So definitely treat that million token mark as a theoretical maximum, not a guaranteed promise. Your actual machine's memory totally dictates the rules here.
Section 4. Building with Agent OS.
So the crucial point is how we actually harness all this power. And getting this running is staggeringly simple. Step 1, install Ollama on your computer. Step 2, run a single command in your terminal. And that's it. It downloads the 5.6 gigabyte model and starts it right up. Once it's pulled, it's immediately ready to be wired in as the local engine for an agentic operating system.
And what happens when you wire it in? Running entirely offline, Quifos successfully drafted a really clean AI Profit boardroom landing page based on just a few core bullet points. It put together a content task tracker. And to really push its coding capabilities, it built some classic apps, a digital clock, a working calculator, and even a little playable snake game. Just picture sitting in a coffee shop with literally zero Wi-Fi, and your local 5.6 gigabyte model is successfully coding working apps for you right on your hard drive. It's nothing short of wild.
Section 5. Quifos versus Ornith.
Now, what's really interesting about this comparison is the core trade-off it presents. We're looking at Quifos 9b against Ornith 1.0, which is another really excellent free local model. When tested side by side on the exact same tasks, Ornith generally has a slight edge when it comes to the final polish and quality of the output. However, Quifos 9b comes back about twice as fast, so it's a win-win choice. It purely depends on your specific workflow. Do you prioritize sheer, rapid-fire speed, or do you need that extra bit of refinement? Either way, you're paying absolutely nothing to run them.
You've also got options when it comes to the physical size of the model itself. If you want something lighter and faster, you can grab the 4.4 gigabyte version. The 5.6 gigabyte model is the recommended sweet spot. Gives you a great balance of speed and quality. But if you have the hardware to handle it and you want outputs as close to the original as humanly possible, there is a near lossless 9.5 gigabyte version. You can literally tailor the downloaded model to perfectly match the memory limits of your specific machine.
Section 6. Honest pros and cons.
And this brilliantly illustrates the exact realities of modern local AI. Let's be objective here. On the pros side, it's entirely free, strictly private, surprisingly fast for its size, and incredibly, it's agent-ready with native tool and function calling. But we have to balance that against the cons. It is still just a 9 billion parameter model, meaning it's not going to rival those massive cloud-based frontier models. That 1 million token context window is incredibly RAM heavy, plus being a smaller model, you will occasionally get messy outputs or sudden cutoffs. That's just the trade-off for running AI offline.
But this brings us to the ultimate value proposition. perfectly captured in our source material with this quote: "A local model running as the engine of your whole agent system is a different level." You see, the real magic isn't just chatting with an AI in a blank terminal. The magic is plugging Quifos into an agent harness, like Hermes or Agent OS, and letting it serve as the autonomous brain for an entire system of workflows, completely privately, completely offline.
Which leaves us with this final, kind of mind-bending thought. If a tiny 5.6 gigabyte model can draft landing pages, code functioning games, and run your agent systems completely offline for free today, what is going to live on your laptop tomorrow? The future of decentralized, private AI is moving incredibly fast, and it is happening right now, right on our hard drives. Thanks for joining me for this explainer. Stay curious and keep exploring.